Good day, viewers all over the world. You are welcome to Toydale online class. Today, we want to start discussing about the different types of partial fractions that we have. And I'm starting with the type 1. Type 1 simply means where we have unrepeated linear factors at the denominator. So how do we resolve this compound fraction into sum of its partial fraction? This is the first one that we have. And that first one is when we have the denominator to be unrepeated linear factors. So how do we resolve this into partial fraction? That's what we're about to discuss this morning. Solution. So if we want to resolve this into sum of its partial fraction, we just say 3. We have 3 all over x plus 2, then x plus 5. So the method of resolution under this, since we have two different factors, linear factors at the denominator, we only split it. We are going to split it as, I'll pick the first one. I will say a all over the first factor, x plus 2, then plus the second factor, b all over x plus 5. That's what we are going to have. So that is what we are going to have. Then at this point, I'm going to multiply through. I will multiply through by the denominator of the left-hand side. That is, if I use x plus 2 into bracket x plus 5 to multiply this, I'm going to have 3 here. Is equal to, if I use this to multiply this first fraction here, this will cancel this. I'll be left with a into bracket x plus 5, then plus, if I use x plus 2 into bracket x plus 5 to multiply b all over x plus 5, I'll be left with b all over x plus 2. So this is the stage. We have been able to resolve this on a straight line. So if we are at that point, then it now depends on the method of resolution that you want to use at this point. Is that we use cover-up method to be able to get our constants a and b, or we use method of comparing coefficients. So we have discussed the two methods of resolution, either comparing coefficients or cover-up method. So I would like to use cover-up method here. In this case now, if I put x to be equal to minus 5, I'm going to have 3 to be equal to, if I put minus 5 here, minus 5 plus 5, that's 5 minus 5, 0. Everything here will cancel out. Then I'll be left with b into brackets minus 5 plus 2. Then here I'm going to have 3 is equal to minus 3b. That's what I'm going to have there. So let's look at that very well. That's what I'm going to have there. If we do that correctly, that is what I'm going to have there. So that at the end of the day, if I divide both sides by minus 3, I divide both sides by minus 3. Minus 3 will cancel minus 3. Then, therefore, b will be equal to minus 1. So we are going to get value of our b to be equal to minus 1. That's what we are going to get there. So since we have gotten the value of b, we can go ahead. We have gotten the value of b. We can go ahead and substitute. And put, also, we say also, put s is equal to minus 2. Then we have 3 to be equal to, if we put s equal to, this is the straight line that we have here. This is the normal equation. If we put s equal to minus 2 here, minus 2 plus 2, that's 2 minus 2. If this we cancel out, then we get value for here. We get value for x for a. So here we are going to have a into bracket minus 2 plus 5. That's 5 minus 2, and that's 3. So if you do that correctly, we are going to have 3 to be equal to 3a. Then we divide both sides by 3. We divide both sides by 3. So a is equal to 1. We are going to get a to be equal to 1. So we have gotten the value of a, and we have gotten the value of b. We have gotten a to be equal to 1 and b to be equal to minus 1. So we now go back to the equation. We go back to what we are given and substitute the value. This is the expression, the equivalence at the first point. We substitute. A is what? 1 all over x plus 2, then plus minus 1 all over x plus 5. Of course, plus times minus will be minus. At the end of the day, everything will be 1 all over x plus 2 minus 1 all over x plus 5. And that will be the partial fractions to this compound fraction. Thank you.